Hello there, this is Austin Jones and I'm from Body Curious, and today I'm going to be talking a little bit about how the body heals itself, in particular when it encounters toxins. Now when I say toxins, arguably everything is toxic to the system to a certain degree, and the body takes what it can in terms of its benefits and it has to get rid of waste, just the same as a car with petrol there is the energy that the petrol provides, and there's also exhaust, which is the waste that comes from the process. And the same is true with everything that we eat and consume. So this series of talks I'm going to be giving over the next few months will be around how the body heals itself. And actually, if we gave it the space, the body is our friend. Often the big problem with regards to disease and dis-ease is that we often get in the way. We actually kind of sabotage ourselves by overloading it with other stuff that perhaps it may not really need, or it just simply needs less of, and giving it quite literally a bit of space and sticking to the basics of what we kind of already know within inside ourselves. So some of you may have seen my model that I used before in terms of how the body works, in particular from a cellular point of view. And the model I use is the idea of a castle. And it's very similar, in fact, is that what you have is you have the keep in the middle, where all the precious stuff is kept, and then you have the wall on the outside, and then you have a moat that has a drawbridge. And what goes on, normally speaking, is goods come in and waste goes out. And this is how the castle functions. Now, when things go wrong, what happens is that if there is a problem, or rather, should we say, if we get an attacker that decides to lay siege to the castle, what happens is the first thing they'll do is they'll stop goods from coming in, and they'll disable our ability to get rid of waste. And that, in essence, it poisons itself from the inside. This is where castles eventually give up, is because they can no longer sustain. They don't have enough resources to survive the sieging army, because basically things get diseased from the inside, often plague or disease, and also they don't have enough fresh resources like fresh water and fresh food to come in. And so basically that is how a siege happens. Now, the very same thing happens with regards to the cell in our body. Now, the easiest way of seeing this is if you get an egg. An egg is the best example we have of a single cell and how it functions in just the same way as a human cell does. What you have is you have the nucleus in the middle where the precious stuff is kept. And then what you have is you have the membrane wall that protects it. And then what goes on there is that you have an exchange of oxygen, and the waste product is in essence carbon dioxide. And in this particular example, I'm going to be oversimplifying it here, is that normally speaking what you have is you have this exchange between magnesium and calcium. And assuming everything is working correctly, is that the fluid inside the cell, which is kind of a salt and water balance, it has to be hydrated well, and it forms quite literally a battery. The cathode, the calcium and the magnesium are in essence the cathode and the anode of a battery, and that combines with the balance of water within the cell, and that literally creates an electromagnetic field. And when this is fully operational, our cell is in essence impregnable. Now, when we get stressed, when there is a disease pattern that happens, or when we're attacked, is that what happens is that magnesium in essence is the first to fall. And what happens then is that we tighten up, quite literally, that each cell kind of goes on lockdown. And so therefore it becomes much harder for there to be the natural exchange, just the same as it is with a castle, is that you have, in essence, calcium and carbon dioxide build up within the cell, and oxygen or oxygenation of the cell, or that oxygen exchange, becomes much harder and less efficient when there is threat, is because everything's on lockdown. And so this is where we're in essence getting poison from the inside, and you can bombard the system with as much oxygen as you like, but the thing is, if the cell is not able to function correctly, then that exchange doesn't happen as efficiently. The electromagnetic field that is normally generated by a well-hydrated, and the balance between calcium and magnesium for that cathode and anode exchange doesn't happen, and then the cell becomes vulnerable. And what's more is it starts to get a buildup of waste within the cell itself, and then we have disease and dis-ease within the system. So a quick breakdown, and again I'm oversimplifying here, is that some of you may have already heard of the Krebs cycle. In essence, this process is how we normally would make energy, is that we have some form of sugar, glucose, coming into the system, and the process is called glycolysis. It goes from glucose to something called pyruvate, and then hopefully, all being well, that then creates the Krebs cycle, or what's called the citric acid cycle, which then gets converted into a form of ADP, which then gets turned into ATP, which is another word for energy. And this is what would normally go on in a healthy cell. Now, we need resources for this to happen. For these things to go from one stage to another stage, we need vitamins and minerals, and in some cases, fatty acids, for this to take place. In the case of getting from glucose to pyruvate, and again I am oversimplifying here, but the principal mineral salts that we need here is magnesium and zinc. To get from pyruvate to the Krebs cycle, we actually need vitamin C, B vitamins, and alpha lipoic acid. Now, alpha lipoic acid generally comes from the way the body produces it from a source of things like coconut oil and also organ meats. And this is normally how the body would get hold of ALA. It produces it itself through a different type of acid. And this is why fatty acids are so important. Now, for the Krebs cycle to function, we also then need magnesium, again, B vitamins 1 and 2, again, alpha lipoic acid, iron, sulfur, and manganese. And then to get from ADP to ATP, we actually need magnesium and sometimes a little bit of vitamin C. So this is why when we talk about the term vitamin, vitamin means vital for life, and our body can't necessarily get them from ourselves. In the certain cases of B vitamins, we can in certain cases. However, we do need to consume these vitamins, and they have to be in a form that is absorbable and useful for the system to make use of them. And they need to be used in combination with the system. So if we're down on some of these, then quite often it interferes, it creates a domino effect, and so therefore we're unable to create energy. And this is just one of many hundreds of different factors in how the cell functions. So something as simple as water, and often people tend to roll their eyes at water. They go, oh yes, hydration, blah, blah, blah. Well, it's actually, hydration isn't just simply about drinking water. And in fact, sometimes you can drink too much water, and what you're actually doing is you're bleeding out electrolytes, in other words, different types of salts from the system. Now, so at every stage in the sense of the cell, we have something called cellular hydration, which, as I said before, you need within inside the cell, you actually need this balance of mineral salts and some silica for this to take part in combination with the water itself. You then also need water to literally detoxify the system. And this is for water-soluble toxins, which are specific. And then you also quite literally need water for the various fluid dynamics within the system. This means something as simple as, say, blood. It's about 98% water. You need good hydration. You need literally water content to allow the lymph system to function correctly. If you don't have enough water in the system, then actually quite literally that lymphatic system ends up becoming more like sludge than free flowing. And then we have to remember, as a body, we are in a hydraulic system. Actually, literally gives us strength. And something else that's undervalued is water is also H2O, hydrogen and oxygen. This is really quite important in terms of supplying energy. And this is something often forgotten. We don't think of water as giving us actual energy. It is, a combination of the food we eat combined with the water, and the water then helps us generate energy. If we are dehydrated, actually the food we eat isn't transposed into energy as efficiently. Some people say actually correct hydration actually enables us to access the energy within the food by a factor of 10. So in all these cases, in terms of how water is involved, we actually need those electrolytes, mineral salts. That means magnesium, calcium, potassium, sodium, these kind of things, and of course silica. The other aspect of the cell is what's called cellular respiration. And this is slightly different than our general respiration in terms of breathing in and breathing out. The cell also needs that same exchange, and that's that oxygen and carbon dioxide exchange within the cell. And for this to happen, we do actually need vitamin C, B vitamins, iron and magnesium for this to happen within the cell. We also need that to help us with better oxygen uptake, and that again requires B vitamins and of course magnesium. Notice the way magnesium crops up quite a bit here. And respiration, in other words, the actual breathing in, breathing out, we need vitamin C, vitamin D, which of course relies heavily on cholesterol, which is our friend, remember, and again, magnesium. So you can see the importance where magnesium itself has a major role to play both in cellular hydration and also cellular respiration. We require this particularly important mineral salt to function at many hundreds of different functions within the cell. So if we're low on it, it makes quite a bit of difference. And the fastest way for us to use up our magnesium and deplete magnesium is, of course, when we get a bit stressed. So this model I'm using, it's one part of what's called the triangle of health, designed many years ago by a gentleman called Dr. Goodhart. And from a biochemical point of view, I'm going to simplify what goes on in our system. So the main inputs, apart from air and water, of course, is proteins, fats, carbohydrates, those vitamins and important minerals, and of course fiber, which is basically insoluble proteins in essence. Yeah? And the output, assuming everything is well, is the primary way we get rid of these things is through our feces, predominantly for fat-soluble toxins, urine through water-soluble toxins, lungs, we're actually getting rid of gaseous toxins, and as a secondary backup, that means that if these aren't working quite so well, there's also a backup for the system, and that is through our mucus and our skin. So quite often when we have problems with it in terms of that mucus or the saliva in our system looking a bit of a strange color, or that say we're having skin problems, then it's an indicator that something isn't going quite so well with the evacuation of toxins via either the feces or the urine or through our lungs. So it's a marker. Now, when it comes to where the toxins come from, internally, we are all those cellular processes, we're producing waste, and this is called metabolic waste. And then the stuff that comes from outside, that means chemicals, toxic metals, radiation, and allergens from the outside. Now, there's an awful lot of concentration these days on all the environment and what we're putting inwards, and does it contain lots of rubbish? And this is certainly interesting. However, it is worth remembering that actually 90% of our waste that the body has to deal with is actually from that metabolic process, and only 10% of the problems come from external sources. So that means that if we're becoming super sensitive to allergens and toxic metals and radiation and other things, it's a good indicator that actually the internal processes aren't working properly. So most of our problems are actually coming from our own system, not actually from the outside environment. The external stuff is actually the feather that breaks the camel's back. And this is something that is often neglected and forgotten about. So the way the body actually deals with toxins comes in something called phase 1 and phase 2, and a middle process. Some people call it phase 1B, and the proper name for it is something called methylation, which I'll explain a little bit later. So the first thing is the body needs to basically convert everything to be as water soluble as possible. So with water soluble toxins, this is very straightforward. And if any other things that would normally be fat soluble, the body will try its best in this first stage to make it more water soluble if it can. The second stage is something called methylation. Now, methylation is very important for steroid hormones. That means testosterone, adrenaline, noradrenaline, estrogen, progesterone, and basically any of the stress hormones. And what's interesting about this particular process is that it's also important for DNA repair and gene expression control, which it's something that is gaining more ground of understanding, is that our system is not set in stone. It is often believed that, you know, what you inherited, whatever genes from your parents or the family line, and you inherit particular disease patterns, which to a certain degree is true. However, what we're finding now is that it depends on the environment you put that cell. If you change the environment, in other words, if you already know kind of where the weakness is, you can actually upgrade and change that genetic expression. And this is where methylation, think of that the particular gene or weakness actually is to do with a failure somewhere in the methylation process, or maybe it's not methylating correctly. So this is where methylation becomes important, is because when that's operating correctly, you can upgrade your genetic expression to something a bit more useful to you, and then you can evolve. And what's called phase 2 is called conjugation. And this is again taking all that hydroxylation and methylation hasn't been able to do, and again it makes a third attempt at trying to convert it into something that is more water soluble. Anything that it can't deal with, that would go into the feces. So this is a kind of a quick crash course of how the body deals with toxins. So what you can see is that all these processes, they require, again, vitamins, minerals, and resources for these things to take place. And without some of these resources, what happens is one or more of these ways of being able to detox correctly will fail or be less efficient, and this causes a domino effect, and then we start to get literally poisoned, and then we become more and more sensitive to those outside things like allergens, pathogens, radiation, etc. So the hydroxylation, that phase 1, that actually requires vitamin B2, 3, 6, 9, and 12, and also all important magnesium and zinc. That phase 2 stage requires something called N-acetylcysteine, which is a sulfur-based amino acid, and this is where sulfur becomes really, really important to be able to deal with plenty of things. And what's interesting about sulfur is about 80% of our sulfur is used for the skin. This is where it's stored and also is used, and so therefore quite often a process called sulfation, which is part of the conjugation process, is it's breaking apart that NAC, N-acetylcysteine, into its different parts to manufacture various things like glutathione and sulfur. Vitamin C, of course, is required, and again, vitamin 5, 9, 12. An amino acid called lysine, which is quite interesting when it comes to things like, say, something like herpes simplex, cold sores, is that what's called the lysine-arginine balance is often a marker when we're a bit stressed, is that we're more likely to get a cold sore. And so these days, what you can do is you either take a lysine supplement and get what's called a lysine stick, and this actually resolves the arginine-lysine imbalance within the system, and the cold sores disappear very quickly. So sometimes one of these markers of getting a cold sore may be an indication that actually either conjugation is not taking place correctly, or you may be low on lysine, as an example. And the last one on that is called betaine HCl, or trimethylglycine, which is basically a form of the stuff that would normally take place within your stomach acids. And this is where stomach function and producing enough acid is vital to the breakdown of both proteins, but also various toxins. So you need this kind of stuff for this to take place. Now, methylation, that intermediate stage, hormones, and this requires to deal with this. Again, vitamin B's again. This is why vitamin B complex is so important as a basic. B2, B6, B9, B12, again magnesium, again trimethylglycine, and vitamin D again. And this is where cholesterol combines with the ultraviolet light from the sun to manufacture vitamin D. And it's said that actually an awful lot of us are said to be very low on vitamin D. But is it to do with our obsession of trying to have low cholesterol diets and taking things like statins to disable the body's ability to produce cholesterol? Because about 80% of our cholesterol is actually produced by our body, not actually from what we eat. So my question around this is and again, finally, after 20 years of lecturing on this, the world is catching up with understanding that cholesterol is actually vital for our health. And in fact, the manufacture of all our steroid hormones requires cholesterol also. It's part of our defense mechanism, and it's also part of the structure of a healthy cell. It is the scaffold of our cell, in essence. Now, something else that is not given too much concentration, but I think it should, is that an amino acid called homocysteine, which again is part of that sulfur group, it is regulated by enzymes which again need vitamin Bs to work. And normally speaking, methylation is okay, while homocysteine is correct. And what normally would happen is it's recycled into something called methionine. Now, the problem with this is that let's say the metabolism of this amino acid requires magnesium again. So one of the markers that happens where kind of the whole cascade of how methylation, that all important middle part of methylation happens, is that when we get stressed, what tends to happen, and again, I know the term stress is overused a bit, is that the drop in magnesium in the system, and there are various different forms of magnesium, of course, is that the cascade of happens, it interferes with not only cellular hydration, cellular respiration, and also it screws with the body's ability to detoxify properly at this methylation stage. So it really is, it seems, you think surely it can't be this simple. It's like, well, in many cases it really is that something as simple as making sure we get enough B vitamins and magnesium can, for many people, be really quite life-changing in some cases. And so if we have a deficiency in B vitamins, if we have a deficiency in magnesium, almost automatically it means we're going to have high homocysteine levels, which by definition means that the methylation process, one of the key components of being able to process all those stress hormones in itself, it's kind of a vicious circle, is that it disables our ability to detoxify correctly, particularly from various steroid hormones and those all-important stress hormones. So in the very time when we're stressed, we often don't eat properly because we don't feel like it, because we're stressed, and because of anyone who's ever read Professor Robert Sapolsky's work on the stress system, Why Zebras Don't Get Ulcers, is that the brain is being told through that fight-flight mechanism that it wants to eat sugary type foods, whereas actually it's the last thing you should be doing, is because when we're stressed, we actually need the reverse. We don't need sugars. What we actually really need is we actually need good quality foods with plenty of magnesium and Bs, and it's the very things that we don't feel like eating because our body is too lazy. It wants cheap energy, whereas actually what we want to be healthy is we need good quality energy, and we need those sugars to be able to go into the cells rather than sitting in our bloodstream. And that's one of the key problems, is that magnesium is also the gatekeeper for glucose. If we don't have magnesium, then glucose can't get turned into ATP, into energy. So quite often, one of the key problems with certain types of diabetes is what happens is we look at the glycemic index of our blood, and it appears we've got plenty of sugar in our system, plenty of glucose, and yet it's not going into the cell and being translated to energy. So what they end up having is they have a marker that says, hey, look, I've got plenty of sugar in the system, and yet they don't have any energy. And this is because magnesium, the gatekeeper, isn't actually opening the drawbridge to say, hey, come on in, guys, we can convert you into energy. So I'm repeating myself here, but that all-important middle process of methylation is dependent on B vitamins, zinc, and your stomach basically operating correctly, and this trimethylglycine, a form of betaine hydrochloric acid. If you have high homocysteine levels, it automatically means you're going to be methylating poorly, which de facto means you are low on B vitamins and low on magnesium. If you also have high homocysteine, that means it directly impacts on cellular hydration. Now the question is, does high homocysteine, is it caused by low magnesium, or does the high homocysteine impact magnesium? It's a circle. Either way around, it means that which is a bit of a chicken and egg really, is that cellular hydration is being interfered with, and one of the markers is a high homocysteine level. And that means you're going to have low mineral salts and low magnesium. And of course, if you have low magnesium, that directly impacts on cellular respiration. So off we go. It's a cascade, it's a domino effect. Now, this is probably one of the better markers when it comes to cardiovascular heart disease, is that is high homocysteine a better marker for, well, do we have arteriosclerosis? Is because what happens is that if we're starting to get high homocysteine, this actually interferes with cholesterol's normal functioning as a repair mechanism, and it gets oxidized and then leaves that kind of that plaque, or it almost becomes like an acid and pits into the veins and arteries. So this is probably a better marker. We're trying to blame cholesterol for heart disease is, again, it's such an age-old myth, and we've known for actually more than 40 years that this is a lie, and yet it keeps coming back. It's one of these pervasive myths that we keep being told. And yet actually it's more likely is that it is long-term stress. We know that 70% of all diseases actually are mainly caused by long-term stress. And this is because, so in essence, the blood becomes kind of like an acid. This is too high levels of sugars in the system, which impacts magnesium, and so therefore we end up getting high homocysteine. And so high homocysteine is a better marker for coronary heart disease, because those oxidized cholesterol plaques, if you like, it's not cholesterol that's the problem. It's actually because we're lacking our ability to methylate correctly and less able to deal and detoxify the system. And so we get, again, it's a domino effect. It's a cascade of problems. And the thing is, if you have coronary heart disease and a high homocysteine level, then guess what? You have a whole host of problems as this cascade keeps on running. And the longer it carries on, the more problems there are. So you have things like, as markers for this problem, it's like, well, how do you know whether you got high homocysteine? Well, generally speaking, those indirect symptoms are things like brain fog, mood, depression, anxiety, irritability, tingling or numbness in the hands and feet due to that nerve damage that happens, fatigue, weakness, high blood pressure, chest pain or angina, which again, if it's contributing to that, poor circulation and extremities because the capillaries and the veins aren't being able to be elastic enough. And then you just the list keeps on going. So what can we do? Well, the basics are, can you get a good source of magnesium and B vitamins that are properly absorbable and bioavailable to the system? Obviously, a good diet. We all know what a good diet is, and yet strangely, when we're stressed, we do have a tendency to want sugar and not actually to eat the very things that will help us, which is things like good, water with electrolytes on a daily basis, and also good quality fats. And we're not talking necessarily just olive oil. We are talking you need a good combination of both saturated and unsaturated fats, and preferably some organ meats, which is less and less common these days, but it must come from organic sources. So it's worth mentioning silica here, is because it doesn't directly play a role in hydration. However, it plays plenty of roles in the infrastructure of the system. So it's important, as mentioned before, at almost every stage with regards to that water and cellular hydration. And what's useful about silica, it is really good at binding to particular toxic metals, things like aluminium, mercury, cadmium, lead, and arsenic. Aluminium particularly is really important, and silica has a particular, let's say, penchant for aluminium, and it's worth considering that. Now, when it comes to detoxification, particularly as I talk about fascia quite a bit, silica is all important in terms of helping the system hydrate the fascial system, which is a triple helix of really well hydrated collagen. And so if you think of silica as being kind of the detox butler, it's not actually directly detoxing. What it is doing, though, it's similar to what I call, in terms of the waste management of a city, in terms of what you actually have is those all important phases 1, 2, and the methylation pathways. That's the waste processing. It's the garbage guys that come down and clear the rubbish. However, you do need good infrastructure. In other words, the actual factories themselves, the roads, the plumbing, and the drainage. And that's where silica comes into the body. It actually makes sure everything else is running correctly. So as I've just written here, if the roads are blocked or the plumbing is leaky, it doesn't matter how good the factory is, waste will build up. And then there's this, worth throwing this in, and maybe I'm overcomplicating the matters here, is in that phase 2, the conjugation aspect of detoxification is actually, interestingly enough, is that one aspect of that conjugation is something called the glutathione pathway. And it's not directly related to making glutathione. That NAC has a complex pathway to become glutathione, But what's important here is that after you have glutathione, that silica then binds together and it helps strengthen, as mentioned before, fascia and the lymph channels and the capillaries. And again, it helps those toxins flow out more freely and more effectively so that glutathione isn't wasted. And again, because silica has a particular penchant for aluminium, it also means that glutathione isn't used up in the all-important process of detoxification. So again, it reduces oxidative stress in the system. And as mentioned here, all-important kidney support in terms of for that excretion of urine, this is where silica seems to play a really important role in renal health and helps the filtration. It makes it better at getting rid of those toxins. So even though silica isn't directly related in terms of toxin processing, it really is important for the infrastructure of the system. So thank you very much for listening. I hope this makes some sense. Again, it's a bit of a crash course on how the body detoxes, and I hope it was nice and clear. If you've got any questions, please drop a message below and send me an email. Okay, cheerio. Bye-bye. This is Austin from The Body Curious.